So now we're going to look a little bit harder at the turning points of a function. So if the graph of a polynomial function has several turning points, the function can have a relative maximum and a relative minimum. So there's not an absolute maximum or absolute minimum. They can have more than one. So if we look at this example here, okay, the maxes and the mins are already given to us. Okay, all of the maxes are like the mountains, and all of the mins are the little valleys. So what would be one of the maxes that we have? So we have the -3, 2. That's a maximum. So -3, 2. Another maximum that I have is 2, 1. So those are both relative maximums. For the minimums, we have -1, -3, and we also have 4, -1. So those are both minimums. Okay, with this comes increasing and decreasing intervals. So intervals are always given in terms of x. So if you were to draw this from left to right, you want to kind of follow the shape of the graph. And where it's going up, it's increasing, and where it's going down, it's decreasing. So if we look at the first piece, so if we start at the lower arrow, so if I start the lower arrow and I draw this, I'm increasing till I get to this turning point. Once I hit that turning point, I am then decreasing. Once I hit that turning point, I'm increasing again. Once I hit this turning point, I'm decreasing. Once I hit that turning point, again, I'm increasing. So the purple represents the increasing, the yellow is the decreasing. We talk about increasing and decreasing intervals in terms of our x values only. So we're looking from left to right. So the first arrow, the bottom left, that's where I'm starting from. That x value, if you think about the end behavior there, the x's are getting more and more negative as you go down. Because this, remember, is in the second quadrant. So if we're over here, my x's are negative and my y's are negative. So we only care about the x's. So actually, let's write out this whole end behavior over here. So on this end behavior, x is going towards negative infinity as y approaches negative infinity. And while we're doing that, let's do the other end as well. So up here, we're in the first quadrant, so my x is going to be positive, and my y is going to also be positive. When we're doing increasing and decreasing intervals, we're focusing on the x terms only. So I care about this value, this value, this one, this one, this one, and this one. So we don't use the y's at all. So we say that it's increasing from negative infinity to -3. So that's the first purple that I drew, from negative infinity to -3. Once we get to -3, the yellow starts to happen, and it decreases until we get to -1. So my decreasing interval is going to be from -3 to -1. And these are not points, they're intervals. So it's not the point -3, -1. It's from -3 to -1. So after I'm there, it's purple again. So now I'm increasing again from -1 to 2. Once I'm at 2, I start to decrease, and I'm decreasing from 2 to 4. And then once I'm at 4, I increase again. So I'm increasing from 4 to positive infinity. And those are my increasing and decreasing intervals. Okay, so they're always written as the x's, so don't pay attention to the y's. And I know it can be confusing, because usually when we talk about things increasing or decreasing, we talk about it going up and down, and that's usually the y's. But in this case, we're going left to right. So from left to right, what's happening? Okay, so we want to find the increasing and decreasing intervals for these examples. So for purposes, I'm going to give you the points for this. So this is going to look something like this. So you have a maximum at negative 2.15, comma, whatever. Okay, it doesn't matter because we only care about the x's in this point. And then this one is going to be 0.15, whatever. So think about this on a coordinate plane. Something like that. So this end behavior, x is going to be negative infinity, y is going to be negative infinity. This end behavior, x is going to be positive, y is also going to be positive. So if we follow this, kind of like the other example, first, we always start from the bottom left, or wherever this is starting from. So if it's a negative, it'll be starting from the top left. So you're increasing first. Then we're decreasing. Then we're increasing again. So we have an increasing interval from negative infinity to negative 2.15. Oops, I'll do that. Decreasing from negative 2.15 to 0.15. And then it's increasing again from 0.15 to infinity. Okay, and the other example, again, I'll just do a rough sketch of this. Okay, so again, it's going to look like this. And we have our turning points. So this is going to be negative 0.86, whatever the y value is. The minimum is going to be 0.64, whatever the y value is. So again, if we draw this on a coordinate plane, x is going to be negative infinity, y is going to go towards negative infinity, x is going to go towards positive infinity, y is going to go towards positive infinity. So we're going to take our increasing first. Okay, so it's increasing, and then it decreases, and then it increases again. Oops. So the first thing that we have is increasing, and it's increasing from negative infinity to negative 0.86. Then it's decreasing from negative 0.86 to 0.64. And then it increases again from 0.64 to infinity. So if you notice something about these increasing, decreasing intervals, is that they always leave off at 1 and then pick up on the same one. So in the previous example, it increased from negative infinity to negative 2.15. And then when it decreases, it picks up at 2.15, or negative 2.15, and then it goes to 0.15. When it starts to increase again, it picks up at that 0.15 and continues. So you're leaving off and picking up at the same value. Okay, so now that we have all of our characteristics down, we're going to put it all together. So given the function, this one, find the following and sketch the graph. So we have to find the intercepts, the x and the y. We got to find the turning points, the end behavior, and the increasing and decreasing intervals. So we sort of did this one with the turning points, with the increasing, decreasing intervals. But let's look at it again. So we want to find the intercepts. So first thing I can do, I'm going to go over here. So I had, my function was f of x equals x cubed plus 3x squared minus x minus 3. So if I want to find the x and y intercepts, well, the y-intercept is always going to be whatever your constant is. So my y-intercept is going to be 0, negative 3. To find the x-intercepts, those are finding the zeros. So I can factor this. If I take, there's 4 terms, so I could group them. take out the common factor, so x squared comes out, and you're left with x plus 3. Take out a minus 1, you're left with x plus 3. I'm going to put x squared minus 1 together, and then x plus 3. So now I'm equaling this to 0. Well, this can break down into x plus 1 and x minus 1 because of difference of squares. And then we have x plus 3 equals 0. So I'm going to solve each one. So x equals negative 1, x equals 1, x equals negative 3. So my x-intercepts are going to be negative 1, 0, 1, 0, and negative 3, 0. So right now I have my intercepts. Okay, I'm going to use the calculator to find the turning points. So if you just find your max and find your min, your turning points should be negative 2.15, comma 3.08 is 1, and your other turning point is 0.15, negative 3.08. So we can wait and do our end behavior and increasing and decreasing intervals once we have this graphed. So let's make a graph here. Okay, so we know that we have a y-intercept at 0, negative 3. So here's my y-intercept. I have x-intercepts at negative 1, 0, 1, 0, and 3, 0. Oh, negative 3, 0. Oops. Right, negative 3, 0. Okay, my turning points are at negative 2.15, comma 3.08. Negative 2.15, 3, like about here. And I'm going to just label it. And then my other turning point is at 0.15, negative 3.08. So I'm going to put that about here. 0.15, negative 3.08. Okay, so now I know what this is going to look like. I can sketch this. So it's going to go from the bottom left, since I know that it's x cubed and it's positive. So it's going to be down to up. So this is going to go from down. It's going to get to our point, change direction, go down, get to the turning point, change direction. Okay, so here's my graph. And then I can do my end behavior from here. So I know my left end, x is going to go towards negative infinity. Y is going to go towards negative infinity. My other end, x is going towards positive infinity as y goes towards positive infinity. So here I have my end behavior. So I'm just going to put a comma there and box those. Okay, and then the other thing we have to do is our increasing and decreasing intervals, which we've done before with this problem, but we can look at it again. So it's increasing to here. It then decreases to here. And then it increases again to here. So I'm increasing. It's increasing from negative infinity to negative 2.15. Then it starts to decrease. So it's decreasing from negative 2.15 to 0.15. And then it's increasing again from 0.15 to infinity. And remember, we're only using the x values for increasing and decreasing. Okay, so now we put everything together, and we were able to graph it and to find all of our characteristics of the graph.